So now we go for types of functions. 11th, if you recall, you already studied what are the function. So let me just remind you what are the function. So you have two non-empty sets x and y. This be two non-empty sets. A rule, or it is also called a relation, rule f from x to y. Rule or relation from x to y is called a function, So on a rule or relation, you're going to put some condition, then it becomes a function. So a function from x to y is a rule in which every x in x has unique image. Unique means exactly one, unique image in y. Every member of x has exactly one corresponding member, that is called image, in the other set y. If this is true, then such a relation is called a function. And here this is called the domain and this is called codomain. If I have like this here, this is a set x, this is a set y. Suppose here I have some member, 3 members. Suppose here I have 4, 6, 7, 8, and I'll take function like this. So you know that this is a function where f of 1 is 4, f of 2 is 6, and f of 3 is also 6. There is a function. F from x to y is a function. This is given to you. Here you know that x is domain. The first set is called domain. The second set y is called codomain. This much you know from 11th standard. And if you recall range of a function, range of f, which is Rf, it is nothing but the set of images, corresponding members, set of images. So it is images means this f of 1, f of 2, f of 3, which is 4 and 6. So it is fx such that x belongs to the domain of the function. So in above example here, range Rf equals to 4, 6, and this always comes from the codomain. So it is always subset or equals to y. Y means here codomain. This is always true. It may be equal, but in general, range, what is this 4? It is f of 1. You take 1 from the domain, so you'll get the f of 1, which is 4. Go to next member. If I take 2, then f of 2, so here 6, and f of 3 is also 6. So this is the range. It is subset or equals to the codomain. Every time these two need not be equal. You see here codomain has 4 members, 4, 6, 7, 8, where range has these 2 members only. Even you can recall this from 11th standard, that if you have, this is a standard result, if you remember. If you have function from real numbers to real numbers, and if I have x equals to ax plus b, you know that this is called linear function. This is a linear function. You know it from 11th standard. And the range of any linear function from R to R, range Rf, range of any linear function from real numbers to real numbers for a linear function is always real numbers. This also you know from 11th standard. So here we use importantly range of the function, you will see, which is very important. That's why I emphasized on this. So this is just a recap of what you did in 11th. Now we go to actual type of functions. So the first type is 1-1 function. Now it is also called injective. 1 1 or injective. Now word itself says, you'll realize what we mean by 1 1 function. So I'll take a function f from x to y. You look at these two functions I'm taking. Before I write explicit definition, let's see these two examples. Here I have some members, here I have some members. Like this, you look at this diagram. One is this. One example is this. Take this second one. Here I have some members. Here I have some members, remember. Let me call this as 1, 2, 3, 4. Here 6, 7, 8, 9, 10. Here let me call, for example, 6, 7, 8, 9. Here let me take 10, 11, 12, 13 and 14. This is just randomly I have chosen x and y. So here you pick up two different members. One is not equals to 2. What about their images? 6 and 7, they are different. If I take 3 and 4 different members, their images are different. If I take 2 and 3, the elements are different, their images are different. So if I pick up two different members from this, so here different members goes to different members. Different, distinct. Look at it, this function. 6, 7, elements are different, images are different. 7, 8, elements are different, images are different. But you go for this. Here 8 and 9, elements are different, but both goes to 1, which is 12. So images are same. So this is not a 1 1 function. 1 to 1, the word itself says different members should have different images. Different members should have different images. Here different members have the same image. You may have like this. I can put here one more. For example, let me put 20. Then 20 may be connected with 12. This is also a function, but 3 different member goes to single one. So this is not a 1 1. Many members goes to 1. So this is sometimes called many one function. Many one. Many one means not 1 1. Not 1 1. Many one means not 1 1. Whereas here different members are having different images. So this is a 1 1 function. 1 1 function. Different members goes to different images. So here this is a precise definition for every x1 x2 in the domain. So here domain is x, capital X. Whenever elements are different, so x1 is not equals to x2, it implies their images must be different. F of x1 is not equals to f of x2. If this is true for every member of the domain, then such a function is called 1 1 function. For every member of the domain, you start with two different members and you show that their images are different. If this happens, then such a function is called 1 1 function. Now, if you recall, the same definition you can write in different language like this also. Contrapositive, if you remember. P implies Q. Mathematical reasoning 11th standard. This is same as not Q implies not P, if you remember. This you know from 11th standard. Contrapositive statement. Statement and its contrapositive are always same. Now I'm writing the contrapositive of this. So you take this first and you write its negation. What's the negation? Not equals to, that is equals to. So f of x1 equals to f of x2 implies not P. Not P means negation of this. This is x1 equals to x2. And this has to be true again for every x1, x2 belongs to the domain of the function. Both can be used freely, remember, to show that the given function is 1 1. Either you can use this Start with two different members, show that their images are different. That is one way. Or start with this, that their images are equal, and show that the corresponding members are also equal. Then also the meaning is it is a 1-1 function. Logically this one and this one are same. Both of these can be used freely, remember. Whichever you like, either you can use this or this. In the above example 2, you look at the example 2 here, f of 12, if you see, sorry, let me write this here. 8 and 9 are different, but what is f of 8? You look at the diagram, f of 8 is 12. What is f of 9? Which is also 12. So their images are different. Members are different, but images should be different. Here images are equal. So therefore that is not a 1-1 function, not 1-1 function, not 1-1 function. And such a function is sometimes called many-one function. Meaning is same, remember, whether I write not 1-1 or I write many-one, both are having the same meaning, remember. When you say that it is not a 1-1, not a 1-1 means it is called a many-one function, remember. You can use not a 1-1 or many-one, both are commonly used word. 1-1 function is also called sometimes injective. This is also standard terminology. This is a synonym. Injective means 1-1 function. The word now clear to different members should have different images, or if you start with this, you must need to show. So in sums, either you start with this and show this, or you start with this and show this much for every member of the domain. And if you want to show that it is not a 1-1, give an example. Give an example for which elements are different but images are same. This suffice that it is not a 1-1. No need, you doesn't require to prove that it is not a 1-1. One example is sufficient. This is called counter example method. You did such things in 11th standard mathematical reasoning, if you remember. If you want to show that it is not 1-1, find two different members whose images are same. But if you want to show that it is 1-1, you need to give the proof. You will see once I start exercise. So this is a concept of 1-1 and many-one function. So next step is onto function. Onto is also called surjective. There injective, here surjective, onto function. So let's see the function f from x to y. I'll take two examples again here. Example 1, you have a function from x to y. One more example, g from x to y. Let's see here, a, b, c. I have three members. I have just three members, or let's take 4 members. Here I'll take, for example, 2, 3, 4. 2, 3, 4, 3 members. Here I have, suppose, let's write 6, 7, 8. Now here, suppose I'll take this way. So this is obviously many-one function. Now you must have realized, not a 1-1. I mean not 1-1 function. Not 1-1, that you know. Two different members are having same image too. Look at it, this function. Now this is, let me call this as 1, for example here. 1, 2, 7. 3, 2, 8 and 4, 2, 8. So here it has 1, 2, 3, 4 members. Here 6, 7, 8. So this is again not a 1-1 function. This is again not a 1-1, that you must have realized now, function G. But if you concentrate at codomain here, so These 1 and 2 are connected with these 3 members, but 3 and 4 are not connected with any member of the domain. That means here you have extra member in the codomain. It is quite possible in a codomain, remember. Look at this. There is no extra member in the codomain. No member left extra in the codomain. So if this happens, then such a function is called onto. So this is an onto function. Look at this, not onto function. Not onto function. Not onto. This is a surjective function, not a surjective function. Now, another way of saying this is, you find the range of the function here, range. What's the range? That is 6, 7, 8 set of images, which is same as codomain. So ये आपका definition बन गया. Function is said to be onto, get the range if it is exactly codomain. So in another language, if I say RF equals to codomain, then such a function is called onto. This is the definition. Look at this. What is the range of the function? Which is 1, 2. You again recall from 11th standard, or as I explained in the beginning, range is set of images. जो सामने के साथ connected members है, that's called the range, 1 and 2. Is it same as codomain? No, you have extra members. So this is not same as codomain. So this is not onto. Not onto, as I mentioned here. So now you have a definition. A function f from x to y is called onto. If this is a definition. Range of f equals to codomain. Second set. Codomain means second set. This set. This is the definition of onto function. Very simple definition. There is no relation between 1, 1 and onto. It is quite possible that the 1, 1 function is onto, not 1, 1 is onto. It is quite possible that the function may be both 1, 1 and onto. It is quite possible that the function may not be none of these two. So there is no relation. If it is 1, 1, it has to be onto. If it is onto, it has to be 1, 1. There is no relation between 1, 1 and onto. But this is the definition. एक भी member कोडोमेन में एक्स्ट्रा नहीं रहना चाहिए. यहाँ पे देखो एक भी एक्स्ट्रा नहीं है. There is no extra member in the codomain. So this is onto. Here you have extra member 3 and 4. So not onto function. Now every time to get the range is not an easy task. So alternatively f is onto if this condition is true. If this is another way of saying onto. Now आप देखो क्या हो रहा है. अगर onto है तो आप यहाँ से you select any member from this. Suppose I have chosen 6. So you have one member whose image is 6, that is 2. Suppose here I have chosen 7, though you have one member 1 whose image is 7. Suppose I have chosen 8, then you have one member, at least one member. यहाँ पे तो 2 है, 3 and 4 whose image is 8. Now come to this. If I choose 1, there is a member. But if I choose 3, do you have any member whose image is 3? No. So this is another way of defining onto, alternative way of saying onto. If function is onto, then for every y in codomain, codomain is y here. This is small y, this is big Y, remember. For every element y in codomain, there is some x in the domain. Here domain is x, such that if I find the image of x, that is if I apply the function, I must get y. So if I can show this is very, very important statement for ontoness, remember. I repeat again, what this says, for every member of the codomain, if there is a member x in the domain such that whose image, that is वो member पे आप function apply कर दो तो आपको y मिलना चाहिए. If this much you can do, then such a function is called onto. It is same as the range of the function equals to codomain. You will realize in sometimes we use this technique, especially theoretical type sum.